Okay, beta. 9th A, roll number 5, get up, read the question. 9th A, roll number 5. My question is, ice at 0 degrees Celsius appear cooler to mouth than water at 0 degrees Celsius. दोनों का टेम्परेचर सेम है, आइस भी और वाटर भी, both of them are at 0 degrees Celsius, but ice at 0 degrees Celsius appear cooler. Why is it so? 9th A, roll number 5. Roll number 5 is not there, then please roll number 6 come forward. If 6 is not there, roll number 7 come forward. 5, 6, 7. If 5 is not there, roll number 6 come forward. Make it fast, bacha, so that we could do maximum number of questions. Unmute your mic. Ninth A, unmute your mic. Which student is coming? Unmute your mic. What happened? Who's coming? Roll number 5 or 6 or 7. Yes, please. Can't hear you if you're speaking, Vijay. But I can't see anybody near the mic which is kept on that table, first table. I think there is some problem. 9C. Yes, a boy is raising his hand. Please come forward. Yes, Pratap, please answer. Okay, beta. Because of latent heat which gets used up. Okay, better. So please, very good. So it says that it is due to high latent heat of ice, that is, ice absorbs the heat energy from the mouth and hence appears much colder. आपके पास आइस है 0 डिग्री सेल्सियस पे, राइट? ये पहले मेल्ट करेगी, सॉलिड स्टेट से लिक्विड स्टेट में जाएगी, सेम टेम्परेचर पे, बट फॉर दिस इट नीड्स सम हीट. तो एज आइस क्यूब इन द माउथ, हमारे माउथ के सरफेस से हीट ऑफ फ्यूजन अब्सॉर्ब करेगी और अपना बिकॉज ऑफ जो हमें माउथ का सरफेस पे वो सरफेस कूलर लगेगा, बिकॉज वहां की हीट चली गई है इसको सॉलिड स्टेट से लिक्विड स्टेट में चेंज करने के लिए. और ये जो हीट है जो यूज होती है स्टेट को चेंज करने के लिए, दैट इज कॉल्ड लेटेंट हीट ऑफ फ्यूजन, राइट? Second. Then next question is, Doctors advise to put strips of wet cloth on the forehead of a person having high temperature. आप देखते हो जब किसी को फीवर होता है तो हम क्या करते हैं, एक हैंकी लेके उसको आइस क्यूब्स में डिप करके या ठंडे पानी में डिप करके पेशेंट के माथे पे रखते हैं, तो उससे क्या होता है? Question is, doctors advise to put strips of wet cloth. You can write down the question, beta. Cloth on forehead of a person having high fever. Having high fever. What is the reason behind it? What is the concept behind it? Ninth है roll number 8. Yes, beta. What happens when we put wet cloth on the forehead of a person suffering from fever?
It will give
Hanji?
cool the forehead.
Cool the forehead. Okay. Please, sir, I'll make you write the full answer. Very good. Sit it up and write the answer. It's correct. That water, while evaporating, जो आपने वेट क्लॉथ रखा है फोरहेड पे, वो हीट से उसका इवेपोरेशन होगा उस वेट क्लॉथ का, एंड व्हाइल इवेपोरेटिंग takes away necessary heat from body of the patient. Write down the answer. You might be knowing what is the answer, but most of the time students are not able to write the correct language. So write down the answer. Body of the patient. And this lowers the temperature of body. This lowers temperature of body. Question is, how does the following affect the rate of evaporation? Affect the rate of evaporation. First factor is surface area. Second factor is temperature. And third factor is humidity. Right? Surface area, temperature, and humidity. How are these factors affected. What happens when temperature, surface area, and humidity increases, and how does it affects the rate of evaporation? So, if you increase the surface area, what happens अगर आप जैसे एक glass full of water if you take, and if you take a broad vessel and fill it with water, तो जो surface के molecules है, evaporation में क्या होता है, surface के molecules escape करते हैं, तो यहाँ पर lesser surface area है, but अगर broad vessel है तो उसके पास greater surface area है जिस पे से molecules जो है water molecules evaporate कर सकते हैं. So if surface area increases, evaporation also increases. Then temperature से क्या effect होता है? अगर किसी भी liquid को आप consider कर रहे हो, if temperature increases, TE is for temperature and KE is for kinetic energy. So if temperature increases, kinetic energy of molecules increases, और इसी kinetic energy की वजह से ये जो molecules हैं, they escape from the surface. ठीक है? So if temperature increases, then also evaporation increases because kinetic energy of molecules increases, which helps them escape from the surface of the liquid. And humidity. Humidity क्या है? Humidity है presence of moisture in air. तो अगर air में already moisture होगा, तो उसमें और ज्यादा liquid जाने का, water जाने का जो tendency है वो कम हो जाएगी, ठीक है? मतलब अगर humid air है तो evaporation कम होगी, right? So if humidity increases, evaporation decreases. ठीक है? Rate of evaporation decreases. So these are three factors affecting evaporation, and how does they affect? Surface area और temperature के साथ evaporation increase हो रही है, but humidity के साथ evaporation decrease हो रही है, क्योंकि वो already saturated होती है air with moisture, with water molecules, तो उसके पास और जगह नहीं होती है water molecules को अपने में रखने की, तो फिर वो evaporation नहीं होने देती है. Right, next is एक statement है that carbon dioxide is taken in a cylinder, and compressed by applying pressure. Compressed by applying pressure. Right, this is the statement given. And then some questions are being asked. So, I think the screen is frozen. I hope you could hear me. Solid. I repeat the answer because the recording मैंने pause की थी, तो जब बच्चे अभी सारे sections ने join नहीं किया, so they could find the answer later. So CO2 is taken in cylinder and compressed by applying pressure. Which state of matter is obtained? So when this gas is CO2, pressure is applied to it, the molecules come closer together and they change into the solid state. This change in state directly from gaseous to solid state can be termed as sublimation or crystallization, right? So the state of CO2 is solid here. Next part of this question is define the process. So what is the process? That process I told you, that is sublimation, right? That process is sublimation. And this is direct conversion of vapor to solid. Generally solid से vapor होता है, but reversely possible here. Yes. Then third part of the question is common name of the product which is obtained. Common name of the product which is obtained, that is called dry ice. Right? Solid carbon dioxide is known as dry ice. Write it down first. Next equation. Next question is, how does melting point of a substance indicate strength of substance? How does melting point of substance indicate strength of substance? Handy, who knows the answer? Who wants to tell the answer? Your voice is not clear. Can you repeat the answer? If anybody was answering? Yes, please. Now, pick up the mic, bring it closer to your mouth and then speak. Pick up the mic, yes. Bring it closer to your mouth and then speak.
Loudly. In this portion, it indicates the density and the mass of the substance. And more the melting point, more will the strength of the substance, because if the substance has more mass and more density, then its melting point will be higher.
Which would mean कि अगर आप कोई भी एक सब्सटेंस लेते हो, अगर आप लेस क्वांटिटी में ले रहे हो तो उसका मेल्टिंग पॉइंट लेस होगा. इफ यू आर टेकिंग इट इन हायर क्वांटिटी उसका मेल्टिंग पॉइंट हाई होगा. इज दैट?
particular substance को मैं बताने की कोशिश करूँ ना कि उसकी quantity.
No, see melting. See, thank you. Good. I'll explain it in detail. See what happens. If you take a substance in lesser quantity, it will take less time to melt, but that doesn't mean it has lesser melting point. जैसे कि water है, चाहे आप एक glass water लो, चाहे आप एक bucket water लो, it boils at 100 degrees Celsius, same boiling point, but one glass of water will take lesser time and a bucket of water will take more time. Because the mass से ये related है. Thing is, कोई भी liquid है, उसकी जितनी intermolecular forces की strength है, that determines its melting and boiling point. ठीक है? Strength of intermolecular forces, the forces between the constituent particles of substance determines its melting and boiling point, right? So every liquid has different strength of intermolecular forces. Suppose you take alcohol, you take water, you take honey. So what happens? This will boil fast because it has weakest intermolecular forces. Then water will boil. It has higher boiling points. Then honey will boil. It has more higher boiling point because of strength of intermolecular forces that increases. Okay? So you can say that melting point is determined by strength of intermolecular forces, and stronger the force of attraction, then more energy will be needed, more energy will be needed to break the forces, and this indicates that they have higher melting point, right? So quantity will reduce the time. If you take smaller quantity, it will reduce the time of melting, but the melting point, the particular temperature at which it melts, that remains the same, and that is determined by the strength of the forces between the particles, between the molecules present in it, right? Next question is, rubber band can change its shape on stretching. Its shape on stretching. Will you classify it as a solid, or will you classify it as solid or liquid? Yes. 9th E, roll number 15. जल्दी से करो, मैं ग्राफ्स भी करूँ. 9th E. If 15 is not there, roll number 16.
Yes, ma'am.
What is the state of the rubber, beta? Solid or liquid?
Solid.
Solid. Why solid? Solid तो उसकी तो fixed shape होती है. आप तो rubber को stretch कर सकते हो.
Because it cannot flow.
It cannot flow. Okay, वो बात तो valid है, पर वो solid क्यों है? ये तो हुआ कि वो liquid क्यों नहीं है? Why is it not liquid? It cannot flow, so it is not a liquid. But why is it solid? It is solid because it regains its shape. It has weaker intermolecular forces, but once it is stretched, it regains its shape, जो उसकी originally थी. ठीक है? Good. बैठो. Take it right because it regains its shape. इसी पे इसका point of difference होता है, that is a fixed shape. ठीक है? If you can stretch it, it regains its shape. Because it has weaker forces comparatively, elastic forces होते हैं उसकी, इसीलिए वो stretch हो जाता है, but it is able to regain its shape, and that is why we classify it as solid, right? Okay, next question is, which property of gas is used in supplying oxygen cylinder to hospital? Which property is used in supplying oxygen cylinders in hospitals? Hospitals में जो ऑक्सीजन सिलेंडर होते हैं या फिर हमारे किचन में जो गैस सिलेंडर्स होते हैं, उसमें गैस की कौन सी प्रॉपर्टी आपको देखने को मिलती है? बोलो. 9th F, रोल नंबर 15, or let's say 16 are there. 9th F. फटाफट बेटा, मैंने ग्राफ वाले क्वेश्चन करवाने हैं. नीड टाइम फॉर दैट. we can't take that much of time. So I'll tell you the answer. So temperature, what do you say? Which property? So property is compressibility. I have told it. Chalo, abhi baitho. Ready, get ready for next question now. थोड़ा सा जल्दी करोगे तो ज्यादा number of questions we can cover. So that compressibility की वजह से oxygen can be compressed and put into cylinders, right? So that because gases are compressible in nature. Okay, next is if you have a glass tumbler containing hot water, glass tumbler containing hot water, and this is kept in the freezer. This water is kept in the freezer compartment of refrigerator. Temperature is less than 0 here. If you could measure the temperature of content of tumbler, which correctly represents a change in temperature, which is going to show the change in temperature when it is kept in freezer. So what happens जब आपने गर्म पानी को फ्रीजर में पुट किया है, पानी का जो भी टेम्परेचर है, मान लो पानी का 50 डिग्री सेल्सियस टेम्परेचर है, ठीक है? तो पहले क्या होगा, वो टेम्परेचर लोअर होगा, ठीक है? कहां तक लोअर होगा? 0 डिग्री सेल्सियस तक. ये 50 डिग्री सेल्सियस पे आपने लिया था, तो वो 0 डिग्री सेल्सियस पे तक लोअर होगा. Then it remains constant. It remains constant because 0 degree Celsius पे that water starts bonding with each other. That water molecules they start bonding with each other, जिसको हम हाइड्रोजन बॉन्डिंग भी बोलते हैं. तो इसमें जो भी हीट absorb होगी, that is not shown here. This is latent heat diffusion. यहाँ पर 0 degree Celsius पे constant line का मतलब this temperature remains same. आपको उस वक्त नहीं पता चलेगा कि ये कहाँ पर गया ये सारी एनर्जी. So that remains constant and after that temperature falls again. ठीक है? तो जब आप hot water को freezer में पुट करते हो, so it starts freezing at 0 degree Celsius. This constant line shows here that temperature remains constant and that heat is being used up by these molecules to get converted from liquid to solid state, right? ये phase change का जहां पर भी आपको constant line graph में मिलेगी, that represents the phase change. ठीक है? Liquid से ये solid में change होगा, so this kind of graph you get for it. Then another question. This question says, graphically describe the heating curve of ice cube. It gets transferred from state of water vapor. Heating curve of ice cube. This is heating curve of ice cube. अब आप reverse process कर रहे हो. So इसमें if you make a graph between temperature and heat absorbed, what will you see? You'll see that initially ice cube जो है that the temperature rises and ये अभी solid state में है. Then the state changes. यहाँ पर this ice melts. The state will change now. Ice melts and then this gets converted to liquid, right? You take ice at 0 degree Celsius, this is solid in state, then you get a constant temperature at which it melts, and then it is converted into liquid state, and then you get constant temperature where it boils, and this gets converted into gaseous state. So this is the kind of graph which you get when you heat ice or when you change this ice cube to the boiling water. Ice cube is solid at state, it melts here, then it changes into liquid state. It is in liquid state here, then it boils here, and then it changes to gaseous state. Right? The graph, and I told you the constant line represents that there is a phase change. Solid से liquid बन रहा है, यहाँ liquid से gas बन रहा है. Change of solid to liquid, that is, the temperature is called melting point, and when this liquid changes to gas, the temperature is called boiling point. Enthalpy or heat, we use the term enthalpy of fusion here, your heat of fusion. और यहाँ हम बोलते हैं heat of vaporization. Temperature remains constant, so we call it latent heat of fusion, and here also temperature remains constant, and we call it latent heat of vaporization. Right? Make the graph. We'll do next of the things in the next class. Till then, take care. Bye.